Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Normal distribution, you have heard the name before. It's part of the S1 syllabus, which is paper 5. It's a pretty technical chapter, so let's get started with the basics of normal distribution. Now, first of all, what is normal distribution? When we talk about many naturally occurring circumstances or characteristics, that is a better word, it follows a normal distribution. So let's read the statement. That is, the normal distribution is a continuous probability distribution that can be used to model many natural occurring characteristics that behave in this way. Now, first of all, when we talk about binomial probability distribution or when we talk about geometric probability distribution, these are discrete probability distribution. They occur for integer values. But when we talk about normal distribution, this is a continuous distribution. It can work for a range of values of the variable. Examples of continuous variable that can be modeled using the normal distribution are as follows. Which one are these? Let me highlight it. The heights of people within a given population, the weights of tigers or any other object in a jungle, errors in scientific measurements, size variations in manufactured objects. Let me show you some more examples. We are talking about the weights, the heights of people. They follow an approximate normal distribution. So this is the weight, this is the frequency density, and by the way, you have recognized this, that this is a histogram. What about the dimension of manufactured articles? It also follows a normal distribution. So for example, this is the length of a bolt. It could be the diameter of a ball bearing. It could be the mass of apples produced from a certain farm and so on. So now, what exactly normal distribution, how is it represented? What we do is that we have this thing which is a bell shape symmetric curve. When we talk about bell shape, a bell has a peak. So if I draw a thin vertical line over here, it has a single peak. Now for some people, this seems very trivial. That what is so special about having a single peak? The thing is, there could be some kind of a graph with a double peak in it. You might see some histograms in which there is a single peak, or maybe there are two double peaks, but this one has a single peak. And it is symmetric. It is symmetric about this value, so let me label this point as 0. And since it is symmetric, there are positive values on the right hand side of 0, there are negative values on the left hand side of 0. It's a bell-shaped symmetric curve, and this is known as the Z curve. By the way, Z stands for standardized score, and we will soon talk about it. Now, since it's a symmetric curve, that means the area to the right should equal the area to the left of this vertical line. In other words, if we talk about area under graph, and we will just limit ourselves to the syllabus, area under graph, that represents probability. And we know that the total probability is 1. That means 50% lies on the right, 50% of the area under the graph lies to the left. Also remember that I'll be talking in terms of percentages, I'll be talking in terms of fractions and decimals. So I have first written a decimal and then a fraction. So percentage and then decimal and then the symbol for fraction. So we would be talking about all these things. So over here, if I highlight this, this is 50% of the area under the graph. And over here, if I highlight this, this is another 50% of the area. So now this is how the normal distribution function and its associated graph looks like. It's a long table. There is a formula, but of course the formula is too difficult, so somebody took the initiative and jotted down all these values. Now it says if z has a normal distribution with the mean 0 and variance 1, then for each value of z, the table gives the value phi of z, where phi of z is probability z less than or equal to z. I'll just explain it in a short while. And for negative values, we have to do this. Now, what is the objective over here? The first objective is that we have to understand how to read this table. And there are two ways of reading this table. For right now, I'll just focus on one thing, that is using the z value to find the p value. What is the z value? That is the standardized score. And what is the p value? P value stands for the probability value. Now, first of all, if I observe over here, and let me just minimize it a bit. If I observe over here, this is z written, this is 1 decimal place values that are written over here. So let me highlight it, this thing. This line over here, it's starting from 0.0 and it's going till 2.9, and there is a logic for that. And not everything will be revealed in the beginning, it will take some time. These are the 1 decimal places value of z. Over here, when I talk about this one over here, this is the 2nd decimal place value of z. And over here, the 3rd one where it also says add, this is the 3rd decimal place value of this. And now also focus on one other thing, that is the shading. There is this value z, and the area to the left of this particular value is shaded. That means all this value over here within this box, and whatever is the way to read it, this value over here, this is the probability, and the probability is the area under the graph. So first of all, this is the probability, and we will use the z value to find the probability, and the probability will be left of z, or let me write it this way, less than z. So now our understanding will be of this table. So I have taken out small pieces of this table and I'll work that out. I have again written over here, the standard normal distribution has a mean 0 and standard deviation 1. Now remember, what is the relationship between standard deviation and variance? Standard deviation square is variance, or I can write variance is square root of standard deviation. That means if the standard deviation is 1, it also means variance is 1. Now symbolically when we write it, this is how we write it. X follows a normal distribution mu comma sigma square. Mu stands for mean, sigma stands for standard deviation, sigma square stands for variance. That means there are two parameters. This is the mean and this is the variance. And we will also focus on the z-score, which is x minus mu over sigma. Whatever is the raw data, we have to standardize it. How can we standardize it? Subtract the mean and then divide by what? Divide by standard deviation. That is how we obtain the value of z. But now this is far-fetched. Right now we are focusing on reading the table. So one other thing, let me write this thing, that z, the standardized normal variable, follows a normal distribution definitely with a mean of 0 and standard deviation of 1 and variance of 1 square. So that is what is written over here. Z follows normal distribution, the mean is 0, the standard deviation is 1, the variance is also 1. And based upon that, this table is created. This curve is replicating this table, information in the table, and that is how it is created. Now, what is the use of this thing? The main thing is, if we talk about heights of adults in different parts of the world, there could be thousands and thousands of means, and there could be thousands and thousands of standard deviations. So calculation of these probability would be a daunting task. It's almost impossible or too time consuming. So someone standardized it according to this formula, x minus mu over sigma, and then they created this thing. For example, let me give you an example. Let's say if you are talking about math and English, and the mean mark in math is 70 and the standard deviation is 10. And in English, the mean mark is 64, the standard deviation is 8. And there is a student, his raw marks in math, let's say it's 80. And there is another student, his raw mark in, let's say, English, let me just change the color, and this thing is 68. Now, I need to understand in which subject did he performed better. I'm not sure. Why? Because the means are different, the standard deviations are different, the scores are different. How can I judge? So the judgment will be based upon standardized score. The standardized score for math would be 80 minus 70 divided by 10, which is 10 over 10, which comes out to be 1.0. And the standardized score for the subject English, that is 68 minus 64 over 8, which is 4 over 8, which comes out to be half. Which score is bigger? This is the bigger score. Therefore, the student performed better in math as compared to English. So that is how the standardized score is helping it out. Coming back to the normal distribution. So in normal distribution, the shaded region is to the left of this. So probability z less than or equal to z can also be written as phi of z. Now having all this information, let me recap it for you. So pause the recording, again go back and have a look. Let me recap it for you also over here. It's a continuous probability distribution. That means the values by default are inclusive. It can be modeling naturally occurring characteristics, heights, weight, length, errors in scientific measurement, size variations, and so on. What we get is a bell-shaped symmetric curve. Area under curve represents probability. Let me write it over here. It's already written. Area under curve represents probability. And since it is symmetric, 50% lies on the left, 50% lies on the right. This z value is 0, positive values on the right, negative values on the left. I'll be working in percentage and decimal and fractions. This is the normal distribution curve. This is the 1 decimal place value. This is the second decimal place value. This is the third. Our focus is to use this table to use the value of z to find the value of p for right now. Later on, we'll be using p to find z. The key thing is left of or less than as shown in the table. Only positive z values are there, 1 dp, 2 dp, 3 dp, and everything over here is what? It is probability. And yes, this table will also be used. Just hold for a second. And we are talking about a standardized normal distribution. It has a mean 0, standard deviation 1, variance is 1. That is how we write it. These are the parameters, just like binomial. X follows a binomial distribution in comma p. Or just like geometric, X follows a geometric distribution with a parameter of p. So it has two parameters over here. This is the standardized score, and this is the example of standardized score. So now we are starting with the first thing, which is using the z value to find the probability value. And I'm just focusing on 1 decimal place, which is pretty basic. So let me highlight this thing. That's right over here. I'll be using this only. Let's say, let me make a column over here. Let's say I'm using the value 0.0. So in front of 0.0, what do we have? So let me choose the right color. In place of 0.0, I have this value, which is 0.5. So basically, this is 0.0 and then the 0, it's giving a value of 0.5, which makes sense. That means if this is the vertical line, this is 0.0, left of this value is 0.5000, double check, 0.5000, which is the same thing as 50%, which we already know. Let me erase this value. and let me choose another value, let's say 0.5. So the 0.5 corresponding value is 0.6915. Let me show it over here. So a thin line for the vertical, for the dividing line. And then let's say 0.5 is somewhere over here. It's not drawn to scale. It does not have to be. This is 0. This is 0.5. And probability Z, let me choose a thin marker. So probability Z lesser than or equal to 0.5. It means what is the probability that the Z value lesser than 0.5, how much is that? So we are talking about this thing. So this thing is 0.6915. It is stated over here right away, which can be written as 69.15%. So this is 69.15%. Let me write this thing in words. 69.15% of the area under the graph, because under the graph area is what? It's the probability, is to the left of Z value of 0.5. Makes sense? And I can also write this thing as phi of Z. That is the same thing as probability Z less than or equal to Z. I can even write this thing as phi of 0.5 is how much? 0.6915. So there are two ways of stating the truth. So this is phi of 0.5 is 0.6915 or 69.15%. They both mean the same thing. Let me show you one other thing. Let's say I am interested in this thing, which is 1.4. So that is this value, which is 0.9192. So 1.40, because 0 is right over there. That's right in front. That is 0.9192. So phi of 1.4 is 0.9192. So 9192. Probability Z lesser than or equal to 1.4 is 0.9192. And let me show it over here. So that is the vertical line like this. And 1.4, let's say it is somewhere over here. Naturally, it is positive, so it's to the right. Positive values are on the right. I'm just focusing on the positive values for right now. So this is 0. This is 1.4. And left of 1.4 is 0.9192. So this region under the graph, this is how much? This is 91.92%. So that is the basic idea for one decimal place. Now let's focus again using the Z value to find the P value for two decimal places. So now I'll be focusing on this thing and I'll be focusing on this part. So I'm not using the whole table, I'm just using part of the table. So this is just like going this way, and then reading the common value. So basically, let me show you one thing, that I'll be going in this manner and I'll be going in this manner, and I'll choose the value that crosses both. So go this way, and then choose this value. Just keep this figure in mind. So let's get started with this. Let me choose a Z value. So let me write, I'm interested in probability Z less than or equal to 0.98. The Z value is 0.98. So over here, let me just choose this thing, 0.9. And I have just drawn the line like this. And I'm interested in 0.98. So this is the 8 value. Let's go like this. So what is the common value? The common value is this one, 0.8365. This is 0.9 from here, 8 from here. This is 8365. So this is giving me 0.8365. Now remember that the probability that we are obtaining, that is given correct to 4 decimal place. The very final answer, according to the level of exam that you're giving, that will be 3 dp. But right now, we are not focusing on the accuracy. Just focus on the concept for right now. So therefore, again, if I draw a vertical line like this, and then if I draw 0.98 somewhere over here, and then let me draw these lines, and that goes like this. So this is 0.98. This is 0. This much is how much? This is 83.65%. That is the basic idea. And let's move to 3 decimal places. This is more technical. Z value to probability value. And we are talking about 3 decimal places. Now a hint over here. Probability, write without the decimals. And then add the number. Let me show you the examples. Now over here, we are interested in this column. We are interested in this column. And then we are also interested in this column. So this is technical. Now let me choose 0.567. So now I'm choosing a Z value, 0.567, and I'm interested in the P value. So first of all, let's go 0.5. So this is 0.5 right over here. That is the line going like this. And then we are talking about 6, this thing. The 6th thing that is going like this. First of all, you are getting this particular value, which is 0.7123. Do you realize it? Let me highlight it for you. This is 0.5. This is 6. This is the common value. So 7123. So write this thing as 7123. So the first thing is done. That was this one. That was 0.5, the horizontal thing. Then the 6 was the vertical thing. This thing is done. And now we are focusing on the 7. Now in the same line, just keep on going till you reach the number which is below the 7 right over here, because that's the 3rd decimal place. So this is 1 dp, this is 2 dp, this is 3 dp. That's the 3rd decimal place. This number is 24. So this value over here, the 7 value is giving me 24. Now add it up without decimal. That is the easiest thing. So 3 and 4 is 7. 2 and 2 is 4. This 1, this 7 over here. And put back the decimal at the end. Put back the dot, the decimal point at the end after the addition is done. So this is the answer. Therefore, let me draw this thing over here. That is the vertical line. And then I have 0.567. So let me just draw it over here. So this is 0. This is 0.567. The area that we are shading, that is to the left of this. So let me just highlight this. That is going like this, and so on. And this answer is 0.7147. That is the probability, or 71.47%. That is how this thing is read. Very simple. Let me do another example. And this time, let me write a value, something like the Z value, the probability value, and let me choose something. 1.047, 1.048, 1.048. Now, first of all, 1.0, that is 1 decimal place because of the 0, 1 and 0. And then this 4 is the 2nd decimal place. This 8 is the 3rd dp. So basically 1.04. So let me go over here and let me draw a line. This is for 1.0. It's going all the way over here. And then 1.0 and then a 4. So we are interested in this 4 and it's going like this. So let me just shift this thing a bit. And what is the common point? The common point right over here is this orange one. That is 8508. All good? All clear? So this is 1.0. We are going this way. This is 4 and we are going this way. So 8508. Write it over here. So this is 8508 without the decimal. And then in the same direction, I'm focusing on 8. So keep on going, keep on going, keep on going, and you enter this column of add, the third DP, and 1.048. So this is 1, this is 2, this is 3, this is 4, 5, 6, 7, and 8. What is it? 19. It's under 8. So now I'd add 19 to it. So 19 plus 8, that is 27. 8527. Don't forget the decimal. So therefore, probability Z lesser than or equal to 1.048 comes out to be 0.8527. And again, if I'm interested in showing this out, so let me write over here, and somewhere over here is this thing. So this is 0, this is 1.048, and this thing right over here is how much? 8527. So this thing over here, this area under the graph, which is the probability, and this is 0.8527. All good, all clear. Now there is this thing also, which is the strip under the main table. So let me scroll it up. That's the main table. And then we have this thing, which is a combination of a p-value. There are 9 commonly used p-values. And then we have the corresponding z-value, which is given over here. Now it says these are known as the critical values for normal distribution. That means now if we are given the corresponding, the p-value, we can quickly write down the z-value without looking at the main table, because that takes still a lot of time. These are the commonly used values. So this is 75%, this is 90%, this is 95%, this is 97.5%, this is 99%, 99.5%. These are very less used. These are frequently used, the first 6 values. So that is what this is all about. So let me write it down. For example, let me choose the 90% value. So first of all, let me draw a vertical line in all of them. So I'm drawing a vertical line like this for each of them. And there would be one other concept that I'll explain it over here. First of all, these are known as critical values. So over here, critical values. And it can work both ways, Z to P or P to Z. So for example, if I choose this value of 90%, so let me choose this value of 90%. So if I choose this value of 90% probability, the corresponding Z value is 1.282. This is 1.282. This is 0. And this area under the graph, that is the probability. That is how much? That is 90%. That means probability Z less than or equal to 1.282 is 90%. Now think for a second. How much is this area? How much is left? We know that the total probability can be written in fraction or integer, that is 1, or 100%. 100% is the same as 1. That means this thing is like 10% or 0.1. This is 90% or 0.9. So keep also in mind the total probability is 1. That means this table will give you the probability less than, and if you want greater than, then use the concept of subtraction from 1 or subtraction from 100%. Keep that in mind. Now let me choose this other value, which is 95%, and this is 1.645. So let me mark this point over here, and this is all approximate. So this is 1.645, this is 0, and this is like 95%, just a rough diagram. So this is 95% or 0.95. Therefore, this region over here, the red region, how much is that? That is 5% or 0.05. Now let's focus on this one, the third one, 0.975 and 1.960. So let me write over here, draw this thing. and let me write 1.96, the z value, this is 0, and then over here this thing is being marked, and then I'm writing over here 97.5%, this point is there, or 0.975. That means probability z is less than or equal to 1.96 is 0.975. Now over here the red one again, how much is that? The red one is 2.5% or 0.025. So greater would be this thing. So now let's use 7 rules to use the z value to find the corresponding probability value. Now rule number 1, and that's how it's written. Probability z less than or equal to a. This can also be written as phi of a. That means read probability directly from the table. Now for simplicity, instead of the whole table, let me use the strip. For example, let me use this 90% value and the corresponding z value. So over here, let me choose a red marker, and over here I'm drawing this vertical line over here, and let me use a blue marker for this particular value of a, and a is right over here. This is 0, this is 1.282. Read the inequality again. In this manner, if I write it, probability z lesser than or equal to 1.8282, which means what is the probability to the left of this particular value? What is the area under the graph? So for 1.282, the corresponding probability is 90% or 0.9. So therefore, I'll write probability z is less than or equal to 1.282, that is 0.90. Now let me scroll all the way up and go to this table over here. I'll get the same answer from here. This is 1.2. And if I go to the right, this is 1.28. That is 8997. And then a 2, that is a 4. So this is 8997 and a 4, which comes out to be 9001, which is the same thing as 90%. All good, all clear? So for simplicity, I'm just using that commonly used critical values, the strip over here. So that is the first rule. Let me highlight it again. What it says is this: whenever we are dealing with phi of a, which means probability z less than or equal to a, that is read directly. So this is rule number 1. Let me write rule number 2 over here. That means probability z greater than or equal to a. And one more thing, since normal distribution is a continuous probability distribution, that means greater is the same thing as greater than or equal to, less is the same thing as less than or equal to. So probability z greater than or equal to a should be 1 minus probability z less than or equal to a, which can also be written as 1 minus phi of a. Now let me use the highlighter again. Let me draw this vertical line. Let me draw this blue line over here. Let me mark this value 0. This is 1.282, and then I'm marking off this red value. So now over here, the green probability to the left was 90%. Therefore, this probability will be 10%. All good, all clear? Now we know that 90% is 0.9, 10% is 0.1. So probability z greater than or equal to 1.282, which is 1 minus phi of 1.282, which is 1 minus 0.900, which is 0.10 or 10%. That means when we talk about greater, and let me use this red color over here, this is 1 minus phi of a. So therefore, I can summarize that less is direct, whereas greater, lesser would be better, Therefore, greater would be indirect, and indirect means subtraction, and this is subtract from 1. So let me also use the color. Lesser is direct and greater is subtract. All good, all clear? So these are the first two rules. So now let's move on to rule number 3. So rule number 3, and what is it about? What about negative values of z? They're not in the table. Only positive values are given. That means we will now use the concept of symmetry because it's a bell-shaped symmetric curve. For example, if I draw this vertical line over here and then draw a vertical line over here, and let me mark a value over here as a and somewhere over here as negative a. This is 0, this is a, this is 0, this is negative a. Now let me shade some region and let me choose a green marker and let me shade this region to the left of a. Just ignore the color that is going on the outside because this is not an art paper. And similarly, let me shade the region which is to the right of A that goes like this, and it's very satisfying to watch. So now, do you think within the limits of human error, is this area the same? The distance from negative A to 0 is the same thing as the distance from 0 till A. That means whatever is the value of A, the same as the value of A except for the negative sign. It's positive, it's on the right hand side. It's negative, it's on the left hand side. So far so good. That means if I write it, probability x lesser than or equal to A, isn't this the same thing as probability x is, actually instead of x, I should use the symbol z. We have not started with x right now. So this is z less than or equal to A, this is z greater than or equal to negative A. That means if I am given this, I should convert it back to this. So that is how the concept of symmetry is applied. That means if I am given a value, let me draw a vertical line over here, let me draw a vertical line over here, and let me choose a value, let's say this value 0.95 and the corresponding z value 1.645. So this is the z value, which is 1.645, and this is the other one. So if I start with this, this is 0, this is negative 1.645, and this region is right over here. And similarly, this negative 1.645 becomes positive 1.645, mirror image. This is 0, and this is the value which is right over here. So that means if this is being asked, probability z is greater than or equal to negative 1.645, let me put in the decimal, that is the same thing as by symmetry, z is lesser than or equal to positive 1.645. Isn't this the same thing as rule number 1 which we just studied? That's right around here. That is what? Lesser is direct, greater is indirect. Lesser is direct because it's a positive z value from here to here. This part was symmetry. So this is what symmetry is all about. That is remove negative sign and then flip the inequality. That is the shortcut. Remove the negative sign and flip the inequality. So z is lesser than or equal to 1.645, which comes out to be 0.9500. That is the answer. So this is 95%, this is 95%. As such, you don't need to draw the diagram. As long as you have understood the concept from the diagram, that is what I emphasize it. That is what you see on Mathematics with Shahab Yaqub. Let's move ahead to rule number 4. Rule number 4 is also about negative z value. And this time, let me again draw the line and you can have a good look at it. So that's the vertical line and that is the vertical line. And let me mark over here a point A. I'll just label it and like this. So over here using a black marker, this is negative A, this is 0, this is 0, this is positive A, this is positive A, and let me mark this region over here, and let me mark this region over here. Again, are these two regions identical? Yes, they are. So therefore, I can say probability Z is lesser than or equal to negative A. What happens? Flip inequality, but even before that, remove the negative sign and then flip inequality. Remove the negative sign and then flip inequality. Lesser becomes greater, which you can also see from the diagram. So these two are identical. That means if I am interested in probability Z is, let me choose a value, let me choose the 99% value, and this is 2.326. So Z is lesser than or equal to negative 2.326. I'll first write this as Z is greater than or equal to positive 3.236, which is rule number 2. And this is 1 minus probability Z less than or equal to 2.326, which is 1 minus phi of 2.326, which is 1 minus 99% in decimal. That comes out to be 0.01 or 1%. That means over here, let me draw this thing again. So first of all, I'm using the purple color for the middle line that goes like this, the middle line that goes like this. And then I'm using the green color over here, the green color over here. And then I'm using the red marker that's right over here, and the red marker that's right over here. I'm using this value that is negative 2.326, and this is 0, and 2.326. So what is the probability that I'm interested in? I'm interested in the probability that the standardized z-score is lesser than or equal to this negative value. That is the small region. Isn't that the same thing? By symmetry, don't forget symmetry, give it utmost respect greater than or equal to 2.326. Now 2.326, the lesser value is 99%. The lesser value is 99%. That's right over here. So we subtract it from 1. Why? Because lesser is direct and greater is indirect. Lesser is rule number 1. Greater is rule number 2. So let me also change the color because I think initially I used the blue color for this one. So let me change it. So lesser is direct, greater is indirect, lesser is rule number 1, greater is rule number 2. Again, let's focus on this. Rule number 1, lesser, direct. Rule number 2, greater, indirect. Indirect means subtraction. Rule number 3, symmetry. Over here, z greater than or equal to negative a is the same thing as z lesser than or equal to a. And rule number 4, again let me write over here, again symmetry is used. That is again negative z value, z lesser than or equal to negative a is greater than or equal to positive a. So therefore this becomes rule number 2. So the summary till now is this. Let me write over here. So first of all, let me make a box, a blue box, and I just need it with color. So that's a blue box and that's a red box. So first of all, let me write over here, that is rule number 1. Probability z is lesser than or equal to a, which is written as phi of a, that is read directly. Read what? Read the probability directly from the z table. Rule number 2, what is rule number 2? That is probability z greater than or equal to a, which is 1 minus phi of a, which is based upon subtraction from 1. And this of course is linked with this. What is rule number 3? Rule number 3 is probability Z is greater than or equal to negative A, which becomes probability Z less than or equal to A. So rule number 3 becomes what? Rule number 1. And what is rule number 4? Rule number 4, probability Z is lesser than or equal to negative A. According to symmetry, it becomes probability Z greater than or equal to A, which is rule number 2. So far we have studied 2 rules. All good, all clear? That means for negative values of Z, let me erase this. What is the rule? The rule is remove or discard negative sign and then flip the inequality. So rule 3 becomes rule 1. So let me highlight this. Rule 3 becomes rule 1, and similarly rule 4 becomes rule 2. So these are the first 4 basic rules. Let's continue the journey. So now I'm interested in rule number 5. And instead of using symbols at this point, let me write over here between 2 positive Z values. So between 2 positive Z values, let me choose 2 values from here. Something like, let me choose the 975 wala, 1.96, and let me choose this thing that is 90% and 1.282. So now what I'll do is that, let me draw 2 lines. First of all, let me choose the color, and I'm choosing a red color over here. Something like this. And I'm choosing a blue one, that is over here. No, let me first choose blue, that's right over here. And let me also make it straight, something over here. Now over here, this is 0 over here. This is 1.282, and this is 1.960. And I'm interested in this area between the graph. I'm interested in the probability. Now focus on this thing. Left of the blue value is how much? 90%. Left of the red value is how much? 97.5%. So let me draw it again. So first of all, over here, the blue value, that's over here. And then the red value, that is more extreme over here. So this is 1.282. This is 1.960. Left of the blue value, this region over here, this is how much? This is 90%. Let's work in percentages. It's easier to talk about it rather than decimals. And over here, left of 1.960 is how much? 97.5%. So I hope you have guessed it that this thing over here is the difference. It's the difference between the 2 probabilities. It's the difference between the 2 percentages. So therefore, 97.5% minus 90%, that comes out to be 7.5%, and that is the answer. All good, all clear? So basically, if you want me to write it as a formula, I can. And let me show you that formula over here. So over here, let me mark a value. Over here, let me mark a value. And this is A, this is B. I'm interested in this thing that's right over here. So therefore, probability Z lies between 2 values, A and B. B is bigger. That is phi of B minus phi of A. In other words, probability Z lies between 2 values, 1.282 and 1.96. So this is phi of 1.96 minus phi of 1.282, which is 0.9750 minus 0.9500, which is 0.0750 or 7.5%. So it's your choice whether you want to remember it using the concept of the formula, or you want to understand it using the concept of graphs. The formula is definitely derived from the graph. So it's the graphical concept that is supreme. But if someone wants to use a formula, there is no harm in it. First time when you have to understand it, the way that I teach it according to the graph and then make you understand it thoroughly, and then you understand this formula. That's how it's supposed to be done. That's how proper statistics, normal distribution is to be taught. This thing is all done, all clear. So rule number 5 is done. Now let's focus on rule number 6. And again, just like this one, let me choose 2 values. And this time let's choose 2 different values. So let me choose a value which is, let's say 95%, and let me choose this value which is 99%. So this is one value over here, but this time I want to use negative. So that's over here. And this red one is over here. Now let's say I'm interested in this probability. And over here, there are 2 z values. One is 1.645 negative and negative 2.326 and negative 1.645. Now, let me just draw a number line. I think that should serve the purpose. So if I have negative 2.326, I can translate it to positive 2.326. If I have negative 1.645, I can write this thing as positive 1.645. So over here, this green region between these 2 values symmetrically is the same thing as between these 2 values. So rule number 6 becomes rule number 5. Why? Because of the magical thing, which is what? Which is symmetry. So all I need to do is this. That first of all, let me write this thing as over here 1.645. Let me write over here 2.326. This is the blue one, that's right over here. This is the reddish one, that's right over here. Left of 1.645 is how much? 95%. So this probability area under graph is 95%. And left of this blue value is how much? That is 99%. So I think you guessed it right. This probability over here is simply the difference between the 2. So over here, since it becomes rule number 5, it's also about the difference. So therefore, I'll write this answer, that is 99% minus 95%, which comes out to be 4%. Let me check my values. I took 1.645 and 0.95, 1.645 negative, 2.326, I took 2.326 negative, and this is 99%, all good, 99, 95, the difference is 4%. Now, if you want me to write it in a formula like this between A and B, so let me write it like this. So let me choose this red color, and I have chosen the red to be the far one. So this is the red color. And this is the blue color between 2 values. That's right over here. And both values are negative. So this is negative B. This is negative A. We are interested in this area. So therefore, probability Z lies between 2 values. The smaller one is negative B. The greater one from the diagram is negative A. When you remove negative sign and all the flipping and symmetry is done, it's phi of B minus phi of A. Let me do the same thing over here. So probability Z lies between negative 2.326 and this is negative 1.645. Once the negative sign is removed, which one is bigger? This is bigger. Phi of 2.326 minus phi of 1.645. This is 99%, 0.99, and this is 1.645, 0.95. This comes out to be 0.04 or 4%. So that is how this rule is also done. So let me highlight this. That is right over here. That is this rule. So again, it's your choice whether you want to use the graphical concept or you want to use the formula. Definitely this formula is based upon the graph. That is your choice. So now this is between two positive z values, different between the two probabilities. This is also difference between two negative z values. So first of all, use symmetry and then it's the difference. So now these two values were negative. This is negative. This is negative. Discard, remove negative signs. Once discarded, this is bigger. Read the probability for the bigger. This is smaller. Read the probability for the smaller. This means read probability. That is what it's asking you to do. Definitely a bigger z value will give me a bigger probability. So a big will give me big. A small z value will give me a small probability. Just do the subtraction. Of course, the probability, the final answer cannot be negative. It is a probability. So just do the subtraction. So far, so good. Now comes the last one, the most tricky one. And this is rule number 7. That is, one z is positive, the other z is negative. Now, this is very technical. And let me choose the 90% value, which is 1.282. Let me choose the 95% z value, which is 1.645. So let me use these two. Now this time, I'm writing over here, this is the positive z value, which is 1.645. This is the negative z value, which is 1.282 negative, 1.282 negative. And I am interested in this area, and let me just make it a bit thicker. That is this probability between these two. Now there is a shortcut also, and there is the conceptual way also. Now what I'll do is that, let me first focus on the blue one. So if I focus on the blue one, that is 1.645, and left of this blue thing is how much? That is 95%. So this thing is 95%. Now, negative 1.282, we know that negative 1.282, if it's right over here, this area over here is the same thing as left of 1.282, which is 90%. So therefore, this is 90%. Therefore, how much is this orange area? This orange area is 10%. So let me write over here 1.282 negative. And this region is how much? This region is 10%. Now think about it. Left of this region is 95%. Left of this region is 10%. Therefore, after drawing a diagram, you can do, let me write the diagram, then subtract if you want to do it this way. So therefore, this is 95% minus 10, that comes out to be 85%. That is the area of the green region under the graph. That is this answer. That's one approach. Now, if you don't want this approach, let me show you another method. And that people use it in the exam because this is more time saving. So let me write over here this blue value, let me write over here as A. And this red value, let me write over here as B with a negative sign. Now just a disclaimer, that is A, B, size does not matter. That means it doesn't make a difference which is bigger, which is smaller. All it makes a difference is the positive and the negative. So we are talking about rule number 7. Between two positive z values, of course, it's going to be lesser than a positive and greater than a negative. So probability z lies between negative B and positive A. Probability lying between these two values, phi of B plus phi of A minus 1. That is the rule. This is rule number 7 without doing anything, without showing any working, just doing everything correctly. For example, if A is how much? We are using A as 1.645. So the blue color value is 1.645. The red color value is negative 1.282. Doesn't make a difference which is bigger, which is smaller. All it makes a difference, yes, this is positive, this is negative. That's all it matters. So if I write probability Z lies between negative 1.282, positive 1.645, phi of 1.282 plus phi of 1.645 minus 1. Now phi of 1.282 is how much? Phi of 1.282 is this 90% over here. So therefore this is 90% over here, or 0.90. And let me not choose this color so that you don't confuse this blue with the other one. Let me just use a purple color. Phi of 1.282 is 90%. Phi of 1.645 is 95% minus 1. This comes out to be 1.85 minus 1, which comes out to be 0.85 or 85%. So therefore the area between, under the graph, between these two values is how much? It is 85%. So now it's your choice whether you want to draw a graph and then work it out, or just go ahead, have an easy life, just use the formula and then get the answer. So basically, let me add a page over here. So now the three rules which are over here for range of values, which ones are those? So this is for range of values of Z. This is rule number 5. Probability Z lies between two values A and B. Both values are positive. Phi of B minus phi of A. Rule number 6. Probability Z lies between two values negative C, negative D. After the negative sign is removed, C is bigger, phi of C minus phi of D. And rule number 7, that is probability Z lies between two values Q and R. Q is negative, R is positive. Therefore, this is phi of Q plus phi of R minus 1. So these two, yes, they are related. These are related by symmetry. And this one is a special one. And your choices are always obvious. It's up to you whether you want to draw a sketch, whether you are interested in just using the formula. All it matters to the examiner that you show all working. You apply all the mathematical principles. You make the things clear with clarity and with coherence and in a concise manner. That is what the examiner is asking for. So that's all from Mathematics with Shahab Yaqub, where you get quality content of AS A-level maths and as well as O-level maths. Stay tuned for more.